Inspecting and following protocol activity in the network allows us to gain deeper insight into the network environment and behavior of individual hosts. And it's by doing this that we can identify potential security issues and track down the source of threats, and really just try to identify what's not normal. So let's dive in and inspect some protocols. And in this lab, we'll be using the ops PCAP, so make sure you have that open before we begin. Let's start by learning how to use our filter. So let's filter for DNS activity. And note that the filter actually highlighted in green, and that means that it's valid. Now, there's a lot of DNS request activity here, so let's actually filter even further. And we can see that there is a request for an A record for the horizons.jpl.nasa.gov website. So let's go and drill down on that one specifically. If we add a dot after the DNS filter portion, it will allow us to use more specific filters related to DNS itself. So in this case, if we wanted to maybe search for query, we could type in .q. We'll then have a narrower list of options for us to select from. And in this case, we can see something like query.name, and we can use that. And Wireshark filters might seem a little awkward at first. That's totally fine. You'll notice that as long as you can think in your head generally what you're looking for, you could search by the first letter or two after a dot, and you'll find the specific filter that you're looking for. And now we need to specify the host. And in Wireshark, we do that with two equal signs as a logic test to say if dns.query.name equals horizons.jpl.nasa.gov, then show me all packets that meet that filter criteria. And here we go. So let's try and figure out what the IP address is for that host name. And we can see it inside of that info column above, but let's go and select where the response is in packet 21 as indicated. And if we open this up and look at the answers header, we can actually identify what the IP address is. And it's actually 137.78.251.144. Now we can filter for traffic that went to this destination IP address. So let's go and create an IP filter for IP destination host. So ip.dst_host equals 137.78.251.144. Okay, so this is interesting. We actually have a lot of traffic going to this host, all in port 6775. Let's follow one of the TCP streams here. And look at this. We actually have clear text information that it looks like some type of login form, and credentials might potentially be passed here. Interesting. And honestly, it seems like there's quite a bit of traffic here as well. So at this point, maybe we should go ahead and Google what is going on with this host and that port and see if we can find any information related to it. So we should Google horizons.jpl.nasa.gov port 6775 and see what comes up. Okay, so we have a link over here. The first one seems like something of interest. Let's check that out. So it looks like a Horizon system that we can access, and look at that. There's actually a telnet connection here, and if that's the case, if we do indeed actually have a telnet connection, then that means that we're transmitting in clear text, which matches up with what we saw inside of following the TCP stream. Very interesting. Now, telnet typically filters through TCP port 23. So let's go ahead inside of our filter and actually filter for TCP.port equals 23 and see what we can find. And look at that. On packet 31145, we actually have the start of a three-way handshake occurring again. So let's follow that and see what we find. Interesting. So this is 100% clear text, and I can see that there's a username and password submitted inside this stream as well. Awesome. So let's recap what we've done here, because this is kind of cool. We inspected some DNS activity first, and that led us to uncover the IP address for the Horizons website. And upon filtering for that IP address, we found a ton of port activity to port 6775. Not to mention a very suspicious looking TCP stream that when we followed it looked like some type of login form. And then by Googling that, we're able to determine that it was a telnet connection. And telnet traditionally routes through port 23. So once we filtered for port 23 activity, we found a three-way handshake that was initiated with telnet, and that contained credentials in clear text. And this is why inspecting protocols is so important. Okay, and this PCAP actually has a little bit more to it, so let's try one more thing. What if we wanted to inspect protocols based on objective? And what if maybe we had an objective like trying to identify when and where three-way handshake connections with the HTTP protocol on port 80 occurred? Well, we can build a filter to identify something just like that. We can filter for TCP.flag conditions, and we know SYN and ACK are part of it, so we can search for TCP_flags.syn, and then we're going to use another operator here of the AND operator. And when we use this operator, it means that both filter expressions on either side of the AND operator must be true for a packet to be displayed. So this filter that I just typed out here is looking for SYN and ACK flags in the packets. And now I just need to throw in the AND TCP.port == 80 component. And now we have the full filter here that will indicate exactly when we have three-way handshake connections being established, or initiated, I should say, over HTTP on port 80. Okay, so it looks like we actually have a lot of handshakes being initiated. And we keep seeing that IP address of 76.223.27.102 pop up. So let's throw on another AND IP.adder == 76.223.27.102 and see what comes up. Okay, interesting. So that kind of narrowed it down quite a bit. So it looks like there's a GET request on packet 685. And what's pretty cool is if we expand the hypertext transfer protocol, the HTTP header, we can actually see all of those HTTP headers that we were looking at inside of the browser developer tools. They're all right here. If we select them on the packet bytes pane, we can see where they pertain to the packet details pane on the bottom left. And now we can actually specify the HTTP response with and http.response. And there it is. That's kind of cool. So let's inspect this now. And check this out. We have an HTTP code with 301 moved permanently. Our request of http://leveleffect.com actually redirected us to a new location of HTTPS. So that means that we can now chase that request further. This has obviously now been moved to an HTTPS connection with 443 as the port. So let's change that. Let's remove the end http.response from the end of this filter. And then we need to go and change the TCP.port to = 443. And would you look at that? There's that client hello, the server hello, there's the key exchange, and that encryption process has begun. So we've effectively chased this all the way down to a redirect that led us to an HTTPS session. And now if we follow the stream over here by right-clicking it and then going to follow TCP stream, all encrypted. However, we have uncovered that there's a Let's Encrypt Authority certificate part of this process. So as you can see, there's a lot of really interesting information that we can find by inspecting and chasing down protocols through a network capture file like this. And this is really good practice because in the next two labs, we're going to culminate it all together and perform what we call network traffic analysis. And that is an investigation.